All right, so today we're diving deep into the world of Eric Cornell.
Ah, Cornell.
The physicist who co-discovered the Bose-Einstein condensate.
Right.
And we've got this fascinating essay by Yorgo Schneppat to guide us.
Sounds like a plan.
So, get ready for a journey into the realm of ultra-cold atoms and quantum mechanics.
Quantum mechanics, always a good time.
You know, what I find really intriguing about Cornell's work is that he actually created this bizarre state of matter.
Yeah, he didn't just theorize about it.
Exactly.
He made it happen.
And it's not just any matter, it's a Bose-Einstein condensate, or BEC for short.
BEC, where all those atoms act like one big superatom.
Yeah, it's like a mind-blowing concept, even for physicists.
For sure.
And Schneppat does a fantastic job of tracing Cornell's path to this breakthrough.
Oh, tell me about it.
He starts way back in Palo Alto, the heart of Silicon Valley.
So right from the start, he was surrounded by innovation.
Exactly.
Makes you wonder if that had any influence on his future impact on technology.
It's an interesting thought, isn't it?
Definitely.
And of course, Cornell had this early passion for math and science.
It's like it was in his DNA.
Then he goes on to Stanford and UC Berkeley.
Honing those skills.
Yeah, and focusing on techniques like atom cooling and trapping, which are absolutely crucial for creating a BEC.
Right, those are the building blocks.
But, you know, I feel like his time at MIT was a real turning point.
MIT, oh yeah.
He was working alongside pioneers in laser cooling.
The best of the best.
It really set the stage for his later achievements.
It's all connected, you know.
And then, bam, 1995.
The big breakthrough.
He and Carl Wieman create the first BEC.
Can you imagine that?
Using lasers and magnetic fields to cool down rubidium atoms to a fraction of a degree above absolute zero.
It's mind-bogglingly cold.
Schneppat really emphasizes just how cold it needs to be.
It's hard to even fathom.
And I think what's important here is that it wasn't just about achieving some record low temperature.
No, it's about what it opened up.
Right. It unlocked a whole new area of quantum research.
Precisely.
A BEC allows us to actually see quantum mechanics in action.
Not just theory anymore.
Exactly. It's like we had these equations on a blackboard.
And suddenly, bam, it's real.
We have a window into this weird and wonderful world of quantum mechanics.
It's like having a front row seat to something that usually operates on a scale way too small to see.
It's incredible, right?
Absolutely incredible.
So Cornell essentially built this bridge between abstract theory
and tangible experimental physics.
A portal to a hidden realm.
I love that analogy.
And I'm guessing this has had massive implications.
Oh, absolutely. Huge.
For example, in the development of quantum computers.
Quantum computers.
To build these powerful machines, you need to be able to control these large-scale quantum states.
And that's where Cornell's work comes in.
He laid the groundwork.
The foundation for something truly revolutionary.
We've all heard about the potential of quantum computers.
Revolutionizing everything.
Medicine, material science, the list goes on.
The possibilities are endless, it seems.
But I'm curious about other areas where his research is having an impact.
Well, let me tell you. Another area where Cornell's work is really making waves is the development of super precise sensors.
Super precise sensors, huh?
BECs, they're so sensitive to external forces.
Right.
Gravity, magnetic fields, you name it.
So they can be used to create sensors with incredible accuracy.
Exactly.
It's like taking those subtle forces and amplifying them.
In a way, yeah.
So we're talking about things like more accurate GPS systems.
Oh, absolutely.
Environmental monitoring to detect those tiny changes.
For sure.
And maybe even medical imaging devices that can pick up the faintest signals.
You got it.
It's amazing how research that started with these fundamental questions
about the very nature of matter
has led to these tangible, real-world applications.
It's the beauty of science, isn't it?
It really is.
Yeah.
And it's not just about the practical side of things.
No.
Cornell's work has even had an impact on how we measure time.
Time.
Yep, time.
How so?
Well, it contributed to advancements in atomic clocks.
Atomic clocks. The most accurate timekeepers we have.
Right. And the precision they achieve is mind-blowing.
It's like fractions of a second.
Over billions of years.
Billions. It's almost impossible to grasp.
It really is.
Yeah.
It sounds like Cornell's work has touched on everything from fundamental physics to the tech that powers our everyday lives.
It's incredible, the ripple effect of his research.
Absolutely. It really speaks to the interconnected nature of science.
It does. And it's not just about scientific achievements.
Right. Schneppat highlights something else, too.
His dedication to teaching and mentorship.
Exactly. He had this passion for nurturing the next generation of quantum physicists.
He wasn't just content with making groundbreaking discoveries himself.
He wanted to inspire others to follow in his footsteps.
To carry on the torch, so to speak.
Absolutely. And not just in the academic world, he was also a dedicated science communicator.
Someone who believed in making the wonders of physics accessible to everyone.
And that's something I really admire about scientists like Cornell.
Me too.
They understand that bridge between the scientific community and the public.
It's so important.
Breaking down those barriers, making it relatable.
Absolutely. And Cornell, he wasn't afraid to venture beyond his own area of expertise either.
No. Tell me more about that.
He collaborated with researchers from all sorts of fields, like material scientists, biophysicists, even companies working on commercial applications for quantum tech.
So he was a real visionary leader.
You could say that.
Someone who made groundbreaking discoveries.
Fostered collaboration.
And helped shape the future of scientific research.
And his legacy goes even deeper than that.
Okay, now I'm really intrigued. Tell me more. What else does Schneeppet reveal about Cornell's lasting impact?
Schneeppet dives into how Cornell's impact goes beyond just his personal accomplishments. He fostered a collaborative environment. You see, he recognized that the big breakthroughs often happen when different fields come together.
Right, like cross-pollination of ideas.
Exactly.
Right.
And his partnerships, they really speak volumes.
What kind of partnerships?
Oh, material scientists, biophysicists, even companies working on turning quantum tech into real-world stuff.
So he had a real vision for the practical applications of this research.
Absolutely.
Yeah.
And his legacy, it extends to those who came after him, too. Schneeppet talks about Cornell's dedication as a mentor.
A mentor, yeah.
Guiding students, postdocs, helping them start their own journeys in science.
So he wasn't just making these amazing discoveries himself.
Nope. He was also taking the time to shape the future of his field.
By nurturing young talent.
Exactly. And not just handing down knowledge. He really encouraged them to think critically.
To challenge those assumptions.
Yep, to push those boundaries.
It sounds like he had a real impact on his students.
Oh, absolutely. Not just their scientific understanding, but their whole approach to research, to problem solving.
So his influence went beyond just the facts and figures.
For sure. And, that impact, it's clear to see.
How so?
A lot of his former students have gone on to do amazing things in quantum physics themselves.
Like a ripple effect.
It really shows the power of good mentorship.
And a dedicated teacher.
Absolutely. And it wasn't just his students who benefited. Schneeppet emphasizes Cornell's commitment to, what's the word?
Science communication.
Yeah, science communication, making all these complex ideas accessible to a wider audience.
It's like he was saying, hey, quantum physics is cool and you can get it too.
Exactly. He knew that science shouldn't be locked away in some ivory tower.
It should be out there for everyone to engage with.
Exactly. He gave lectures, did outreach programs, even wrote about it.
Breaking it down into something everyone could understand and enjoy.
He had a real knack for that.
Making even the most mind-boggling parts of quantum physics relatable.
It's a gift for sure. And Schneeppet, he doesn't just focus on Cornell's achievements. He talks about the bigger implications of his work.
And what the future holds for quantum physics.
Right, like the potential of quantum computers and simulations.
Quantum computers? Everyone's talking about those.
And for good reason. Schneeppet thinks they could completely revolutionize fields like medicine and material science.
Really? In what way?
Well, imagine being able to model how molecules behave with such precision.
I can't even picture it.
It's like zooming in to a level we've never seen before.
And that could lead to...
Oh, who knows? Maybe even personalized medicine based on your unique genes.
Wow.
Or how about designing materials with specific properties?
Like custom-made materials?
Exactly. Imagine room temperature superconductors, super strong, lightweight materials for spaceships. The possibilities are endless.
That's mind-blowing.
And don't forget climate modeling. Quantum computers could give us the power to create super accurate models of our climate.
Helping us understand and maybe even solve some of the problems we're facing.
That's the hope. And, it's not just about the practical applications either. Schneeppet talks about the potential for discovering totally new and exotic states of matter.
Like what?
Think fermionic condensates, quantum spin liquids.
I don't even know what those are.
Exactly. It's stuff that pushes the limits of what we thought we knew about how matter works.
It's like opening up a whole new universe of physics.
Exactly. And it all builds on the foundation laid by Cornell and his colleagues. And Schneeppet, he also highlights the continued potential for advancements in precision metrology.
building on Cornell's work with those atomic clocks and ultra-sensitive sensors.
Right. Imagine even more accurate GPS, even more sensitive environmental monitoring, maybe even medical imaging that can catch diseases before they even start.
All because of the work of scientists like Cornell.
And that's what Schnepphat really drives home. Cornell's legacy goes way beyond those specific discoveries.
It's about the impact he had on the whole field of quantum physics.
Inspiring new scientists, pushing the boundaries of knowledge, and paving the way for all these future innovations.
It's amazing how one person's work can have such a ripple effect.
It really is. And Schnepphat, he makes sure we remember the human side of Cornell, too.
The importance of curiosity, the power of working together, the responsibility of scientists to share their discoveries with the world.
Exactly. It's a powerful reminder that science isn't just about cold, hard facts.
It's about pushing the limits of what we know.
Exploring the universe.
And using our understanding to make a better future.
Couldn't have said it better myself. So there you have it. A glimpse into the life, work, and legacy of Erich Cornell as seen through the eyes of Jörg Schnepphat. This deep dive into the world of quantum physics has been truly fascinating.
We've explored groundbreaking discoveries, peeked into the future of technology, and I think we've all gained a deeper appreciation for the impact one scientist can have on our world.
We owe a big thanks to Jörg Schnepphat for giving us such a rich and insightful look at this incredible scientist.
And to our listeners, until next time, keep exploring, keep asking questions, and keep diving deep.